8-bit multiplication. We are moving 10 to BL register, then 80 to AL register, and we are executing MUL BL. MUL BL means AL into BL. The result will be stored in AX register. Okay, so this 80 into 10, it will be 800. Its hexadecimal is 320. So we can see AH will carry 03 and AL will be carrying 20. Okay, let us execute this program using Turbo Debugger. See, here we are moving 10, that is 0A to BL, then 50, that is ET to AL, then MUL BL. See, now AX is 0150. After this MUL BL, AX will be changing. AH will carry 03 and AL carries 20. So this is 8-bit multiplication. AL register content will be multiplied by 8-bit register or memory, and the result will be stored in AX register. This is 8-bit multiplication. Here this multiplier is stored in data segment, that is 10. Here you can see MUL num. Okay, so here also it is doing 80 into 10. Okay, this is a program. We should get answer 800 in hexadecimal 320. Let us run this program in Turbo Debugger. The program is loaded. The program is loaded. AL register is loaded with 50 hexadecimal, that is 80 in decimal. Then we are performing MUL num. Num is 10. So now you can see the AX register is 4450. So after executing this MUL num, the AX content will be changed. Let us see, execute this. Okay, AX register carries 320, that is 03 in AH and 20 in AL. Multiplication. The multiplier is number 200 in decimal. Then we have move AX, 800, that is we will be doing 800 into 200, it will be 1,60,000, and we are expecting the result in DX and AX ratio. Okay, this 32-bit result, that is we are multiplying AX content, the 16-bit register AX with 16-bit number 200. Okay, and we are expecting the result in DX and AX. So that is 16-bit multiplication. This is the program. Let us execute this. This is the program. Move AX, okay. Here we are loading 800, that is 320 in hexadecimal to AX register, the 16-bit value. Then MUL num is 200. and you can see here ax equal to 320 and dx is 0000, and after executing this mul num, dx and ax contents will be changed. It will be storing the result of this multiplication. See this mul bl. After mul bl, dl is 02, that is total dx register 0002, and x register h contains 71 and al contains 00. Our expected result dh equal to 00, dl is equal to 02, h equal to 71 and al equal to 00. The resultant hexadecimal will be 00027100. That will be the result, and that will be the hexadecimal of 1,60,000. This is 16-bit multiplication. Next we are keeping the multiplier in 16-bit register in bx. Here also we are doing 800 into 200. Okay, instead of this memory variable, we are using 16-bit register. Okay, we should get the same result. Okay, let us load this program in Turbo Debugger. Okay, 320 is 800, and we are moving bx equal to 00 c8. c8 is nothing but 200. Then we are performing mul bx. Okay, we are expecting dh equal to 00, dl equal to 002, ah equal to 71, al equal to 00. Okay, let us perform this multiplication. Mul bx. Let's just see the change in ax and dx. Okay, dl equal to 00, dh equal to 02, ah is 71, al is 00. That is the expected result. So this 16-bit multiplication, ax content will be multiplied by the 16-bit value. The value can be, the multiplier can be in a 16-bit register or in memory location.